solid gets warm enough, it melts. To explain what's happening, imagine you can see how the particles in a solid are arranged. They're in a fixed framework, vibrating but not straying far from their main position. When energy is supplied, the particles vibrate more violently and become free to move. The solid changes into a liquid. Melting involves a transfer of energy. This can be illustrated by putting an ice cube in a sealed container, leaving another one empty. The air on the left is at 25.5 degrees Celsius. As the ice melts, it takes energy from the surroundings. The temperature of the air in the right-hand container has fallen by about 3 degrees. Energy is also needed to change a liquid to a gas. So, what's happening to the particles this time? In a liquid, the particles are free to move around. Heating causes them to move around more quickly. Those which have enough energy escape from the liquid, forming a gas. This is evaporation. Ether evaporates at room temperature. It's taking energy from the surroundings and disappears in less than 5 minutes. It's possible to see how different liquids take heat from their surroundings using thermometers wrapped in string. They all start off at room temperature. The string absorbs the liquids. Number 1 on the left is a control. Number 2 is dipped into water, 3 into ethanol and 4 into ether. As soon as the string leaves the liquid, evaporation gets underway. The temperature of thermometers 3 and 4 quickly begins to drop. As the liquids evaporate, they're taking energy from the string, the air, and even the bulb of the thermometer. So, which has taken most energy from its surroundings? Liquid 2, 3, or 4? Gases can also be changed into liquids. For this to happen, they need to be cooled. Liquid nitrogen is extremely cold. Immerse a balloon full of air in it and see what happens. The balloon shrinks and becomes brittle. Inside, you can see a liquid. It's liquid air. This time, the balloon is filled with carbon dioxide gas. Immerse it in liquid nitrogen and it cools rapidly. What's inside the balloon this time? If a gas gets cold enough, it changes into a solid. This is solid carbon dioxide. See how it changes back to a gas at room temperature.